Inverse matrices. Matrices. A matrix is denoted by its dimensions, or rather its rows and columns. For example, 2 by 2 matrix would be a matrix that has 2 rows, 2 columns. A 3 by 4 matrix would be a matrix that has 3 rows and 4 columns. We have special types of matrices, and one special type of matrix in particular is a square matrix of order n, and it's basically a matrix with n times n, or the same number of rows as columns. So for an example, 2 by 2 matrix, 3 by 3, 4 by 4, etc. The number of rows are the same as the number of columns. And just as a fact, only a square matrix can have an inverse. So with that being said, we shall find the inverse for the following matrix. Keep in mind that only a square matrix can have an inverse. This matrix has 3 rows, 3 columns, which classifies it as a square matrix, so we can find its inverse. So we'll take a look at the calculator solution. We'll enter the matrix into the calculator. So in order to do that, we'll use our matrix function. So it's second and matrix. We're going to scroll over to edit, and we're going to edit matrix A, which is already highlighted. So notice that it's a 2 by 2. I'm simply going to hit enter, and I'm going to overwrite those values, and we're going to change that to a 3 by 3. Just make sure that we press enter after every entry. So now we'll enter in our elements of our matrix. And now we'll return to the home screen by pressing second and mode, which is the quit key. In order to find the inverse, we'll use the matrix function on our calculator. So we'll simply go back into our matrix. We're going to select matrix A, and we're simply going to hit the inverse key on our calculator and enter. Notice that we can change the decimals to fractions, so we'll use the math key. And the first option here says that we can change whatever we're given to a fraction, so we'll hit enter once and we'll hit it again. Notice that it only shows the first couple of rows in this matrix. However, I can scroll over to the right and I can see that third column. So our resulting matrix is as follows.